So there may come a time when the directions say to solve using the full circle, or to solve using restriction from 0 to 2 pi, something along those lines. And honestly, I believe that this is the easiest of the three directions to solve for, because what it means is your answers can only be between 0 and 2 pi. And the good news about this is you have the possibility of getting more than one answer to it. So if you end up with more than one answer, that's totally fine. It's actually expected for majority of the points for this. So without further ado, let's go ahead and jump straight in. So if you'll notice, these are exactly the same problems from the last slide. I'm actually going to use the same problems for every single one, for the third one for the all possible as well, just to keep things simple. But we'll go ahead and solve this. We'll do so by taking the arc sine of both sides. And again, the question is asking, when does sine of theta equal root 2 over 2? So looking at our unit circle here, when does sine of theta equal root 2 over 2? Sine is your y value. So that ends up being here and here at pi over 4 and at 3 pi over 4. Now here's the great thing about it, is because we're choosing all values between 0 and 2 pi, that means we're using everything on here. So my answers are just straight up pi over 4 and 3 pi over 4. I can choose both of them because both of these are between 0 and 2 pi on the unit circle. And that's it. So these next few ones, we're going to do the exact same thing. Give yourself a little reference so that you can figure out where it is, but all you do is put down both values. So in this case, we're taking the inverse sine. So again, this question's asking, when does sine equal root 3 over 2? So when does sine of theta equal root 3 over 2? I'm going to draw myself a little unit circle. Sine is your y value. So I'm asking when my y value equals positive root 3 over 2. That's up here at pi over 3 and 2 pi over 3. Since both of those are on the unit circle, both of those are my answers. I don't have to worry about any restrictions because our restriction is from 0 to 2 pi. So if it's on my standard unit circle, it is one of my answers. Arc sine negative 1/2 equals theta. So when does sine of theta equal negative 1/2? Well, in the last one, we had to worry about falling inside of those restrictions. But in this one, again, we don't have to. Sine is your y value. When y value is negative 1/2, that's there and there, at 11 pi over 6 and at 7 pi over 6. In principal values, we had to try and draw out a number line to make sure that it all fell within the restrictions, but these are just straight our answers, 7 pi over 6 and 11 pi over 6. So at this point, a lot of people feel like they've gotten it. I'm going to still strongly encourage you guys to try out these new problems and see what your answers are. I'm going to give you guys a second to pause it and then figure out the answers, and I'll show you the real answers in just a moment. So go ahead and pause it and try and figure them out. And the correct answers are right up here for you. Let's make sure we know how we got those answers. So first we need to get the theta by itself. So we take the inverse cosine of both sides. And the question is, when does cosine of theta equal root 2 over 2? Cosine is going to be your x value, so x value being root 2 over 2. Notice it's not even a pretty unit circle here. I'm just using it as a reference to myself. I don't care how pretty or nice it looks, all I care is that I've got the general idea. So at pi over 4 and at 7 pi over 4, which means because there's no restrictions other than just being on the unit circle, our answers are just pi over 4 and 7 pi over 4. For this one, we can take the arc cosine just to mix it up. When does cosine of theta equal root 3 over 2? I'll be a little bit more careful with my unit circle now. Cosine is the x value, so I'm looking for x being root 3 over 2. That's there and there at pi over 6 and at 11 pi over 6. Again, no restrictions. Don't have to worry about knocking one of those answers out of there. Pi over 6, 11 pi over 6. Both of those are my answers because there are no restrictions other than just being between 0 and 2 pi. Last but not least, let's go ahead and put an inverse cosine of both sides. When does cosine of theta equal negative 1/2? Cosine is our x value, so right up there and right down there at 2 pi over 3 and at 4 pi over 3. So with no restrictions means that both of those are going to be our answers. Again, one more set of problems that's a little bit more difficult. So as I show it to you guys, please take a moment to pause the video, try and figure out the answers, and I'll show you the actual answers in just a moment. So here are the answers to those problems. Let's go ahead and solve through it. Take the arc cosine of both sides, arc cosecant of both sides. And again, we need to think about this as cosecant is the reciprocal of sine. So really, we can think of it, if we take the reciprocal of both sides, I'm doing a little thought bubble here, I'm going to think of it as if it's 1/2 equals sine of theta, because what I did is I took the reciprocal of both sides. Taking the reciprocal of both sides is going to give me this right up here in our thought bubble. So that's just a little trick that I've discovered as I've gone through here. It helps me with the problems. Some people have done enough of these problems where they can just say, nope, I'm going to deal with it as 2. I know when cosecant of theta equals 2, and as you go through your unit circle, those of you who know where that is, it's going to be right here and here at pi over 6 and at 5 pi over 6, which are our 2 answers. I'm getting a little bit sloppy as I'm writing through here. My apologies. Now we take the inverse tangent of both sides. And with tangent and cotangent, it really boils down to, do you know how to find the tangent and cotangent of things? Practice, practice, practice. That makes this unit so much easier. So when does tangent of theta equal √3 over 3? That happens whenever, well, tangent is y over x. So in order to get that √3 over 3, it's going to happen anytime your y value is 1/2 and your x value is √3 over 2. And again, it could be positive, positive, or it could be negative, negative, in order to get that positive √3 over 3. So that's going to happen where our y value is 1/2 and our x value is √3 over 2, or when our y value is negative 1/2 and positive √3 over 2. That is at pi over 6 and 7 pi over 6, which means since there's no restrictions, both of those are the answer. Last but not least, let's go ahead and take the arc cotangent of both sides. And our question is, when does cotangent equal negative √3 over 2? Using the same process that we did for tangent, we know cotangent is x over y. In order to get negative √3, we need to have an x value of √3 over 2. Well, if the x value is positive, the y value has to be negative. Or the x value can be negative and the y value can be positive. So looking at our rough unit circle, for those x values to be √3 over 2 and 1/2, or negative √3 over 2 and positive 1/2, that's there and there at 5 pi over 6 and 11 pi over 6. So again, both of those are the answers. 6 and 11 pi over 6. In this case, you will never get an answer of negative because a negative value is not between 0 and 2 pi. This is where all of our answers should lie, and if you go through and do a numeric timeline, or number line for those, then you'll find out that every answer we gave this whole thing will fall between 0 and 2 pi.